your test that this review goes over is on sections 2.4, 2.6, 2.7, 2.8. Once again, this review focuses majority or all of 2.7 and 2.8. So like I said, at the very end of this, I will tell you what to expect from 2.4 and 2.6 as well. If I were you, I'd study the quiz that I gave back to you for 2.6 and 2.4, as well as the review from there. Because a lot of the stuff that you see on the review or on your quiz, you could see tomorrow. All right. So first thing that we're going to look at is going over questions from 2.7. You're given that f of x is equal to 3 minus x squared, and g of x is equal to 1 over x squared minus 4. The first one that you're finding here is f plus g of x. So if we're finding f plus g of x, we're just going to take f of x and add it with g of x. We said that f of x is the 3 minus x squared. If we add that with g of x, which is 1 over x squared minus 4, we're going to first find our least common denominator, which in this case is the x squared minus 4, and multiply it by the top and the bottom of that first term, or first set of terms, which turns it into a fraction. So this is going to give us the x squared times 3 is 3x squared. X squared times negative x squared is a negative x to the 4th power. Negative 4 times 3 is negative 12. And negative 4 times negative x squared is positive 4x squared. This is all over x squared minus 4. And you're adding it to 1 over x squared minus 4. If the top we just combine like terms, we are going to have 3x squared plus 4x squared is 7x squared. The negative x to the 4th power goes next. Then you have negative 12 plus 1, which is negative 11, all over x to the 2nd power minus 4. Now you can leave it in this form, or you can write the top in standard form. It's up to you. If you were to write the top in standard form, it would just be negative x to the 4th power plus 7x squared minus 11, all over x squared minus 4. Because you have a denominator that has x in it, you are going to take the denominator and set it to be not equal to 0 in order to find your domain. For this one, we move the 4 over by adding it to both sides. You have x squared cannot equal 4. Then you take the square root of both sides to get x cannot equal plus or minus 2. If x cannot equal plus or minus 2, you're going from negative infinity up to negative 2, not including the negative 2, so it gets parentheses, with a union from negative 2 to positive 2. Again, both those get parentheses, with a union of 2 to infinity. And that would be your domain. So that literally just says every single number is included for x except negative 2 and 2. For your next one, you're doing f minus g of x. So the only difference between the top one that we did and this one is that the sign between the two fractions, which is the 7x squared minus x to the 4th power minus 12 over x squared minus 4, there's going to be a negative between the two. So the only thing you got to do is combine like terms. So with this one, the negative 12 minus 1 just turns this into negative x to the 4th power plus 7x squared minus 13 over x squared minus 4. And again, this one was your f minus g of x. Once again, with this one, you have a denominator where the x is there. So set that denominator to where it's not equal to 0 and give your domain. So your domain is going to be the same thing that it was for the one before this, so you cannot have negative 2 or positive 2 equal to x. So you're going from negative infinity to negative 2 with a union from negative 2 to positive 2 with a union from 2 to infinity. The negative 12 came from the very top. So right in here. You're using the same exact thing. So instead of me rewriting it as the 3 minus x squared minus 1 over x squared minus 4, I just took what I had in fraction form for the 3 minus x squared over 1 and used that instead.
So it's the same?
It's the same exact thing. The only difference is that the second one, you're subtracting the 1 over x squared minus 4. The first one, you were adding it. Okay. If we look at the next one, you have f times g of x. So you're just taking f of x, which we said is the 3 minus x squared, and you're multiplying it by g of x, which is 1 over x squared minus 4. Remember, when you multiply fractions, if this first one is a fraction, you put it over 1, and then you multiply straight across. So if we multiply straight across, we just have f times g of x is equal to 3 minus x squared over x squared minus 4. Do you have an x in the denominator anywhere here? Yeah, it's in the x squared minus 4, which is the same thing as the two ones that are before this. So your domain is the same exact thing. So from negative infinity to negative 2, with a union from negative 2 to positive 2, with a union from 2 to infinity.
What happens if you don't have an x in the denominator?
You don't have to, the domain would be all real numbers. You got to think back for your domains, back to I think it was the first test that you took this quarter, when it gave you different expressions and asked for the domain. So remember, when x is in the denominator, you set the denominator expression not equal to 0. If x is underneath the radical and the radical is not in the denominator, you set the expression greater than or equal to 0. And then if the denominator has a radical and the variable is in the radical, you set the expression under the radical to just be greater than 0. For your next one, you have f divided by g of x. So again, the f of x, f divided by g of x. Your f of x is the 3 minus x squared divided by f of x, which is g of x, which is 1 over x squared minus 4. So remember, when you're dividing fractions, keep, change, flip. So that's 3 minus x squared times x squared minus 4. FOIL this out. The 3 times x squared is 3x squared. 3 times negative 4 is negative 12. The negative x squared times x squared is negative x to the 4th power. Negative x squared times negative 4 is a positive 4x squared. From here, write it to where your terms that are like terms are combined. So it's going to give you negative x to the 4th power plus 7x squared minus 12. So that's your f divided by g of x. At any point when you did this one, was there a denominator that included the x? Yeah. Here. So you have to give your domain as if that denominator had the x in it. So what was the term, or what was the expression in the denominator? The x squared minus 4. That gets set not equal to 0, and then you solve. So your domain is the same exact thing as all the rest of them from here. So negative infinity to negative 2 with a union from negative 2 to positive 2 with a union from 2 to infinity.
If it's not in your final answer, why are you doing that?
It doesn't have to be in your final answer. It's anywhere in the expression. So like if you looked at this and let's just say x was 2. If you plugged in the 2 from the very beginning, that would give you 3 minus 2 squared, which is 4. 3 minus 4 is negative 1. Divided by 1 over 2 squared, which is 4 minus 4. 1 over 0 is undefined. You cannot divide a number by an undefined number. So that's why we find what the domain can be, regardless of where that x is in your denominator, if it's in the beginning, the middle, or the end. If we look at our next example, these are weird. These tell you that f of x is 4x minus 2, and g of x is 5 minus x squared. A tells you to find f of 2. That means you're finding f of 2, and then taking whatever that is, and plugging it in for x and f of x. Bless you. So if we first find f of 2, we're finding f of 4 times 2 minus 2. The 4 times 2 is 8, minus 2 is 6. So we're really doing f of 6. If we're doing f of 6, plug the 6 in for x and f of x. That's 4 times 6 minus 2. This will then give you 4 times 6 is 24, minus 2 is 22. So f of 2 is 22. If we look at B, we have g of 3. So we're first going to find g of 3, then we're going to plug that in for x in g of x. So g of 3 is going to be 5 minus 3 squared. The 3 squared is 9. 5 minus 9 is negative 4. That's just g of 3. You still need to plug that in for g of x and get g of negative 4. So g of 3, you're plugging in the negative 4 now into g. So 5 minus negative 4 squared. The negative 4 squared is 16, so that's 5 minus 16, which gives you g of 3 is equal to negative 11. For your next question, again, you're using f of x is equal to 4x minus 2, and g of x is equal to 5 minus x squared. A tells you to find f of g of negative 2. So plug the negative 2 in for g of x. Once you get whatever that is, plug that in for x and f of x. So we're going to first find g of negative 2. So that's going to be 5 minus negative 2 squared. That gives us 5 minus 4, which is 1. So g of negative 2 is equal to 1. Take that 1, replace it with the g of negative 2, and find f of 1. To find f of 1, you're going to have 4 times 1 minus 2. So from here, your 4 times 1 is 4, minus 2 gives us 2. So f of g of negative 2 is 2. For B, we're finding g of f of negative 2. So this just says take negative 2, plug it in for f of x, whatever you get from that, plug it in for g of x. So to find f of negative 2 first, we're going to do 4 times negative 2 minus 2. 4 times negative 2 minus 2. For this one, the 4 times negative 2 is negative 8, minus 2 gives us negative 10. So f of negative 2 is 10. Take that negative 10, plug it in, and into g of x. So g of negative 10 is going to give us 5 minus negative 10 squared. The negative 10 squared is 100, and 5 minus 100 is negative 95. So g of f of negative 2 is equal to negative 95. For your next set of questions, these give you f of g of x and g of f of x. We're still using, so you're still using f of x is 4x minus 2, g of x is the 5 minus x squared. If we're going to find f of g of x, take g of x, plug it in for x and f of x. So this is just going to give us 4 times 5 minus x squared minus 2. Distribute in the 4. That's 20 minus 4x squared minus 2. And then combine your like terms. So that's going to give you f of g of x is equal to negative 4x squared plus 18. Now, these don't ask you for your domain, but if they did ask you for your domain, there is no part in here where you have a fraction. There's no part where you have a radical. So it would literally be all real numbers. So from negative infinity to positive infinity. For B, we're finding g of f of x. So we're just plugging in f of x for x in g of x. So that means that we're going to have 5 minus x squared. So f of x is 4x minus 2 squared. You have to FOIL this out. You can't just raise the 4x to the power of 2 and the 2 to the power of 2. It doesn't work that way. So this is going to give you 5 minus 4x minus 2 times 4x minus 2. FOIL this out. You have 5 minus 16x squared minus 8x minus 8x plus 4. From here, remember, you still have parentheses around what you just multiplied. So you're going to combine like terms inside there. It's going to give you 5 minus parentheses 16x squared minus 16x squared plus 4. And now you'll distribute the negative into the parentheses. So your final answer here is going to be g of f of x is equal to 5 minus 16x squared plus 16x. This is x to the 4th power, not x squared. I'm sorry. This is x to the 4th. This is x to the 4th. This is x to the 4th. No, it is x squared. It's just this one's not x. That's why. Okay, so backtracking, x squared. X squared. Now this is 16x squared. There we go. And then it's minus 4. So from here, you do have like terms that you can combine with the 5 and the negative 4. So this is just going to be rewritten as g of f of x is equal to negative 16x squared plus 16x plus 1. And then again, with this one, if it asked you for the domain, you don't have anywhere here where x is in a denominator, so it would just be from negative infinity to positive infinity. For your next set of examples, they still come from 2.7. We'll get to 2.8 after this section. So these ask you to find your domain as well as the given functions. So for the first one you have is f of g of x. So again, we're just plugging g of x in for x in f of x. So that means that we're going to do 3x minus 1 in for x in 4 times x, which we'll use as 3x minus 1 plus 7. We distribute the 4 in. That gives us 12x minus 4 plus 7. We combine like terms, and that f of g of x is equal to 12x plus 3. Your domain for this, again, there is no point in this where x is in the denominator, so it's all real numbers. So your domain goes from negative infinity to positive infinity. For your next one, you're finding g of f of x and its domain. So you're taking f of x, plugging it in for x in g of x. So this is going to give us 3 times f of x, which is 4x plus 7 minus 1. Distribute the 3. That gives you 12x plus 21 minus 1, which is g of f of x is equal to 12x plus 20. Now, once again, is there anywhere in this where x is in a denominator or in a radical? No. So your domain is all real numbers. So from negative infinity to positive infinity. The next part of this asks you to find the inverse of these functions. This is from 2.8. So remember, when you're finding the inverse of a function algebraically, you're going to change the f of x to be y. Then you're going to switch x and y and resolve the equation for y. When you give your answer, you're always going to write it as f to the negative 1 of x to represent that it's the inverse. If you do not write it as f to the negative 1 of x and you keep it as y, you are going to get points taken off. So if you look at the first one, you have f of x is equal to 7x squared plus 6. Again, we're going to write this as y is equal to, so y equals 7x squared plus 6. We're going to then switch x and y. So that's x is equal to 7y squared plus 6. And then we're going to solve for y. So we're going to move the 6 over first, subtract it from both sides. We have 7y squared is equal to x minus 6. We're going to divide each side by the 7. And get y squared is equal to x minus 6 over 7. And then we just take the square root of both sides and give f to the negative 1 of x is equal to the square root of x minus 6 all over 7. For your next one, you have f of x is equal to 7 minus 5x cubed over 4. We're going to rewrite this as y is equal to 7 minus 5x cubed over 4. Then we're going to rewrite this to be x is equal to 7 minus 5y cubed over 4. First thing we're going to do here to get y by itself is multiply each side by the 4 to get rid of the denominator. These cancel out, and you have 4x is equal to 7 minus 5y cubed. Get your y by itself. Subtract your 7 from both sides. That leaves you with negative 5y cubed is equal to 4x minus 7. Divide each side by the negative 5. That leaves you with y cubed is equal to 4x minus 7 over negative 5. Take the cube root of both sides, and you have y, or f to the negative 1 of x, is equal to the cube root of 4x minus 7 over negative 5. Now, in the past, I've stressed to you that you cannot leave a negative in the denominator of a fraction. For the purpose of tomorrow, if you leave the denominator in the fraction, or in the if you leave the denominator negative, I'm not going to mark things off. Okay, so don't worry about that. Worry about making sure that you get y by itself and you rewrite as f to the negative 1 of x. If we look at our next one, we're finding the inverse of f of x is equal to 6 plus the square root of 2 plus x. Rewrite this as y is equal to 6 plus the square root of 2 plus x. Then switch your x and y. So x is equal to 6 plus the square root of 2 plus y. Get your radical by itself first. Subtract your 6 from both sides. You have that the square root of 2 plus y is equal to x minus 6. From here, get rid of the radical on the left side. Raise each side to the second power. FOIL out the right side. This is going to give you 2 plus y is equal to x squared minus 6x plus 36. Combine your like terms on the right side to where you have 2 plus y is equal to x squared minus 12x plus 36. Now move your 2 over, subtract it from both sides. You have y, or f to the negative 1 of x, is equal to x squared minus 12x plus 34. For your last question, you have f of x is equal to the square root of 36 minus x squared. Again, we're going to write this as y is equal to the square root of 36 minus x squared. And then we're going to switch x and y. So x is equal to the square root of 36 minus y squared. And then solve for y. So we're going to square both sides. So you have x squared is equal to 36 minus y squared. Move your 36 over by subtracting it from both sides. You have negative y squared is equal to x squared minus 36. Divide each side by the negative 1. So y squared is equal to negative x squared plus 36. From here, take the square root of both sides. You have y or f to the negative 1 of x is equal to the square root of negative x squared plus 36. So additionally, other than what you see on this review, you can expect to see these these parts from 2.4 and 2.6. From 2.4, you are going to have to find the rate of change. You can see it from a graph. You can see it from a table. You can see it being given to you by 2x values. From 2.6, you're going to be given a function and asked for the transformations that are happening. You're also going to be given a function and asked to tell whether it's odd, even, or neither. Remember, for odd, even, or neither, algebraically, you're plugging in -2, you're plugging in 2. If it gives you the same number when you plug in both those 2's, it's even. If they're opposites, they're odds, and they're two totally different numbers, it's neither.